Did you know that low water cutoff failures are the leading mechanical cause of boiler accidents? Nearly a third of all boiler accidents are attributed to the low water cutoff. If the low water cutoffs are maintained and tested, that risk drops dramatically. Today on Boiler Room Detective, we're discussing how to test and maintain a float type low water cutoff for a steam boiler. My 14 boiler books are available at TF Campbell, Pronto Heating Supplies, Amazon, and heatinghelp.com. I'm Ray Wohlfarth, and we're diving deep into the float type low water cutoff on low pressure steam boilers. If you service, operate, or maintain steam heat systems, this could save a boiler, maybe a building. Think about what happens when the boiler runs dry. The sections overheat, the metal weakens, water suddenly returns, causing violent thermal shock. And now we've got cracked sections or worse, an explosion, all because the low water cutoff wasn't maintained. Here's how a low water cutoff works, why it fails, and the step by step maintenance you should be doing. First, let's discuss how it works. Inside a float type low water cutoff, there's a bowl and a float assembly. The control mounts at the boiler's normal water level and connects via piping. The water level in the float mirrors the boiler's. The brass float rises and falls with the water level in the boiler. As the level drops, it can energize a feedwater pump or valve, and if it drops further, it can cut power to the burner. Simple mechanical reliability, unless mud, scale, or a stuck float prevents it from moving freely. That's why maintenance is non-negotiable. A safety note: all of this work should only be performed by qualified technicians following lockout tagout procedures, local codes, and the manufacturer's manual. Always shut down the boiler, relieve pressure, and let it cool completely before starting. I recommend pulling and inspecting the float assembly at least once a year. To do that, I use the following method. Shut down the boiler and allow it to cool fully. Drain the water level below the low water cutoff so you don't get splashed. Have a new gasket ready from your wholesale supplier. Don't reuse the old one. Remove the screws or bolts holding the float assembly. Place them in a magnetic tray or safe container so they don't disappear down the floor drain. Been there, done that. Carefully pull out the float assembly. I like to wash it in a slop sink so I can clearly see its condition. Inspect the float. It must be intact, undamaged, and completely dry inside. No pinholes or waterlogged floats. Check that the float and bellows move freely up and down with no restriction or sticking. Clean the bowl thoroughly. Look for mud, dirt, buildup that could jam the float. A long screwdriver works great for reaching inside. Clean the mating surfaces on both the control body and the float assembly. Remove the old gasket material with a razor or knife. Then use a wire brush on a drill. Avoid aggressive scraping that could scratch or dent the surfaces and cause leaks. Inspect the opening for any remaining debris that could make reassembly difficult. Check the electrical compartment for any signs of water or steam leakage. If you see corrosion or moisture, replace the head assembly immediately. Once you're done, install the new gasket. Carefully slide the float assembly back in. It may take a little wiggling. Clean the bolt threads if they're rusty. Finger tighten the screws first, then snug them evenly in a crisscross pattern like tightening a flange to avoid warping. Torque to the manufacturer's specifications if available. Let's look at two popular McDonnell Miller model float low water cutoffs. The Series 67. This float control works as either a primary or auxiliary low water cutoff. For auxiliary use, a manual reset switch is added. McDonnell Miller recommends replacing the entire control every 10 years or sooner if damaged. On the Series 150, it's used as a primary low water cutoff. It has two functions. First, it starts the feed pump or opens the feed water valve as the boiler level drops. If the level drops further, a second set of contacts shuts off the burner. This is an automatic reset control. McDonnell Miller suggests replacing the head assembly every 5 years. Always follow the specific manual for your model. Replace it sooner if the float is compromised or movement is restricted. The annual teardown is important, but you also need regular blowdown testing, daily or at least weekly, depending on your system. McDonnell Miller strongly recommends a dual valve blowdown setup for their 150 series controls. It prevents water hammer from sudden steam condensation. Perform the test when the burner is firing and water is at normal levels. Open the upper valve number 1 slowly, then open the lower valve number 2. Watch the sight glass. As the water level drops, the feed pump should start. As it drops further, the burner must shut off. Slowly close the lower valve number 2, then the upper valve number 1. Confirm the water level rises, the burner restarts, and the pump eventually shuts off. Always watch the burner actually trip during blowdown. Make sure water returns properly and everything resets accordingly. Poor water treatment accelerates buildup. Good chemical treatment plus consistent blowdown keeps your float moving freely. Bottom line, a well-maintained low water cutoff is the difference between a safe, reliable steam boiler and a potential disaster. Drop a comment below. How often do you test or tear down your low water cutoff? Daily, weekly, annual? If you want more real-world boiler room detective stories, boiler training, or maintenance tips, hit that subscribe button and turn on notifications. Stay safe out there. Your boiler and the building it heats depends on it. This is Ray Wohlfarth, Boiler Room Detective, and I'll see you on the next case.